A three-phase delta system is implemented for several key reasons. Firstly, delta systems facilitate efficient power transmission over substantial distances. This efficiency is achieved through reduced voltage drop and minimized power loss during transmission. Secondly, delta systems offer enhanced reliability. They can maintain operation even if one phase experiences a failure, ensuring a more dependable power supply. Thirdly, delta transformers often present a cost-effective solution compared to Y transformers. Corner grounding involves connecting one of the delta system's terminals to the electrical ground, serving two principal purposes. Firstly, it enhances safety by providing a pathway for fault currents to flow to ground, thereby reducing the risk of electrical shock or equipment damage. Secondly, it establishes a neutral point within the system, enabling the connection of single-phase loads. In a corner-grounded delta system, one of the three phases, typically referred to as the wild leg, exhibits a voltage that differs from the other two phases. This voltage disparity arises because the neutral point is shifted relative to the phase voltages. The wild leg voltage is approximately 1.732 times higher than the phase-to-phase voltage. This elevated voltage poses a significant hazard to improperly connected single-phase loads, potentially causing overheating or damage. Historically, delta systems were commonly employed in industrial settings where efficient power transmission and the ability to manage unbalanced loads were essential. Some typical applications included powering large electric motors in factories or machinery, providing electrical power for cranes, pumps, and other heavy equipment, and supplying electricity to distribution networks in rural areas. When working with delta systems, adhering to proper wiring practices is of paramount importance. Single-phase loads should never be directly connected to the wild leg without implementing appropriate precautions. It is crucial to utilize a transformer to isolate the wild leg or to employ properly rated circuit protection devices to limit fault currents. Delta systems were originally used because they could provide power for large motors and other high-power equipment. They are still used today in some industrial applications, but they are becoming less common as Y systems become more prevalent. One of the biggest advantages of a delta system is that it can continue to operate even if one phase fails. This is because the other two phases can still provide power to the load. This is a significant advantage in industrial settings where downtime can be very costly. Another advantage of delta systems is that they can handle unbalanced loads. This means that the load on each phase doesn't have to be equal. This is important in industrial settings where different machines may draw different amounts of power. However, delta systems also have some disadvantages. One of the biggest is that they can be dangerous if not properly installed and maintained. The wild leg, in particular, can be a safety hazard if not handled correctly. Another disadvantage of delta systems is that they can be more expensive to install than Y systems. This is because delta systems require more complex wiring and transformers. Overall, delta systems are a good choice for industrial applications where high power, reliability, and the ability to handle unbalanced loads are important. However, they are not as common as Y systems and can be more dangerous and expensive to install. The corner-grounded delta system is a type of three-phase electrical system where one of the phase conductors is grounded. This type of system is typically used in industrial applications where there is a need for a high degree of reliability and safety. One of the main advantages of a corner-grounded delta system is that it provides a path for fault currents to flow to ground. This helps to protect equipment and personnel from electrical shock. Another advantage of a corner-grounded delta system is that it can continue to operate even if one of the phase conductors is lost. This is because the other two phases can still provide power to the load. The wild leg is a phase conductor in a corner-grounded delta system that has a voltage that is 1.732 times higher than the voltage of the other two phases. This high voltage can be dangerous if it is not properly handled. Single-phase load should never be connected directly to the wild leg without proper precautions. It is important to use a transformer to isolate the wild leg or to use properly rated circuit protection devices to limit fault currents. If a single-phase load is connected to the wild leg without proper precautions, it can be damaged or destroyed. In some cases, it can also cause a fire or explosion. The wild leg is a safety hazard that should be handled with care. Here are some safety precautions that should be followed when working with corner-grounded delta systems with wild legs. Firstly, always de-energize the circuit before working on it. Secondly, use properly rated tools and equipment. Thirdly, never connect single-phase loads directly to the wild leg without proper precautions. Fourthly, inspect the system regularly for any signs of damage. Fifthly, if you are not qualified to work on corner-grounded delta systems with wild legs, contact a qualified electrician. Delta systems offer efficient power transmission, enhance reliability, and are cost-effective. Corner grounding provides safety and enables connection of single-phase loads. Wild leg voltage requires caution. Proper wiring and safety measures are crucial. Delta systems are used in various applications such as powering motors, cranes, and rural distribution. Delta systems offer advantages like continued operation during phase failure and handling unbalanced loads. However, they require careful installation due to potential safety hazards. The wild leg poses risks if not properly managed. Delta systems find use in industrial settings with high power demands. Understanding these aspects is crucial for safe and efficient electrical work. The voltage of the wild leg in a high-leg delta system is approximately 208 volts when the other two phases are 120 volts to neutral. This voltage can be calculated by multiplying the 120 volts by the square root of 3, which is approximately 1.732. Therefore, 120 volts times 1.732 equals approximately 208 volts. It is important to note that this high voltage can be dangerous if it is not properly handled. Single-phase loads should never be connected directly to the wild leg without proper precautions. It is crucial to follow proper wiring practices when working with delta systems. Single-phase loads should never be connected directly to the wild leg without proper precautions. It is important to use a transformer to isolate the wild leg or to use properly rated circuit protection devices to limit fault currents. Delta systems are still used in some industrial applications today. It's also important to remember that electrical codes and regulations may vary depending on the specific location. Always consult with local authorities and qualified electricians to ensure compliance with all applicable requirements. Delta systems were once more prevalent, but advances in technology and changes in electrical distribution practices have led to greater adoption of Y systems in many areas. However, delta systems continue to serve a vital role in specific industrial and commercial applications where their unique characteristics provide advantages. Understanding the principles and safety requirements associated with delta systems is essential for electricians and other electrical professionals. This knowledge ensures safe and efficient operation of electrical systems in various settings. Delta systems are designed to efficiently transmit power, ensure reliability, and offer cost-effectiveness. The corner grounding aspect focuses on safety by creating a ground path for fault currents, thus reducing the risk of electrical hazards. Also, it establishes a neutral point, which makes it possible to connect single-phase loads. The wild leg poses a higher voltage, requiring careful handling to avoid damage or hazards. Delta systems have found their use in industries, powering large electric motors and heavy equipment, and also in rural distribution networks. It is critical to follow proper wiring and safety measures, especially when dealing with single-phase loads and the wild leg. The key is to isolate the wild leg using a transformer or implement properly rated circuit protection.